So Amy, can you see my screen? Hello, Professor Shaker.
Yes, sir. Your screen is visible, sir.
Okay, okay. So shall I start or I still need to wait?
I think we can start, sir.
Okay, okay, okay. So I wonder, Professor Yadav is here or not?
No, he's not. He has another meeting.
Okay.
But I will request him to join towards the end if possible.
Okay, okay.
Dr. Jyotsna is there.
Okay, so I think the procedure will, I will first introduce about the program of the IPPS, and then I will introduce about my institute. And then I will ask my student, Amy and RK, to introduce what they are doing in our lab. And at last, I think we will accept a few questions from students, no matter what kind of questions, like study abroad, this kind of logistic problem. So either way is okay. So I will start the first program introduce. So can you see the screen?
Yes, sir. It is visible.
Okay. Hello, everyone. I'm Professor Zhuang, and I'm from National Sun Yat-sen University. And I am the chair professor in the Institute of Medical Science and Technology. So today, on behalf of our science college, I would like to introduce about our PhD program. So in our university, we have an international PhD program for science. This program is special for receiving international students. So in this IPPS program, I think we have 6 groups. And the 6th group actually including all the departments and the institutes in our science college. So you can see first one is physics group, and the second one is the biggest one, chemistry group, and the third one is mathematics groups. And then we also have the subgroup is called synchrotron radiation and neural brain application group. And this group actually also belongs to the physics group. And the next is biomedical science and technology group. That is where we are. Okay, so in our university, we have 4 medical related institute. Okay, the first one is biomedical science institute, and the second one is the medical science and technology institute. And we also have precision medicine institute and pharmaceutical institute. So all these 4 institutes belong to this group. So any one of you are really interested about medical science and technology, you can apply for IPPS. Then you can choose any professor in this group. Okay. So actually, this program we already have maybe 3 years and 2 or 3 years. So I think the student number.
Hello, Professor. Actually, your PPT is like the slides are not changing.
Oh, really?
Yeah, you need to go to full screen and then.
So
right now we are seeing the first page.
Really?
Yeah.
So I need to. Okay, I will stop the share and then we try to reconnect. Okay.
Okay. Yeah.
It's okay. Can you see the?
Yeah, we can see the first page.
You should start the slide now. The slideshow.
So this one.
Yeah, we can see the second page.
So you can see the second page, right?
Yeah.
Okay. So let me. So can you see the third page?
No.
No.
So how about? Okay. So how about now?
Yeah, now we can see it.
It's okay.
Okay. So I think we just show this kind of screen because once I full screen, you cannot see the. Okay.
Yeah.
So you can see we also have the we call the body talk, and we also have the some kind of parties in the end of the year. So you can see that my student Amy here. Okay, and we also provide a English academic workshop for teaching students how to write the English paper. Okay. So I think the student number right now may be over 30. I think maybe 30. Yeah, and they all distributed to different departments. Okay, but IPBS they have their own office, so and their own staff. So I think is a fully operation program. And now you can see the internship and the job opportunity. I think this, we also signed an agreement with this company and especially for the chemistry group. So if you apply for the chemistry group, you also can apply this internship. And I think that the most important thing is the NSYSU also provide a scholarship. Okay. So you can see the NSYSU scholarship is tuition fee is waiver for maxima for 3 years. Okay, and we also have a added doctoral student entrance scholarship, and we will provide a student 15,000 NT dollar for each month, and the dormitory, I think we also provide a dormitory fee waiver, but a very limited quota. So I think usually you need to pay by yourself. Okay. So another, we also have the Taiwan Scholarship, but Taiwan Scholarship is provided by the Taiwan government. So you need to extra apply to the Taiwan embassy. Okay. And we have two admissions. So one is fall admission and another one is spring admission. So right now we by the end of the March 31, and you can apply for the fall admission. And then we gonna go to the review after you apply, and we will notify you by June 15. And you need to submit the enroll confirmation by student by July 15. And the letter of acceptance we will send to you, and then you can apply for the visa. And because from India to Taiwan, you need to apply visa. Then the start, the semester, new semester is in the early of the December. So you need to booking the flight and the flight to Taiwan by September, the early September. Okay. So regarding of the COVID-19 pandemic, and we have very strong border control. So this is very important message for you guys. So we have CEC commander, and we have face mask policy, and we have quarantine enforcement. So later on, I will introduce more about the quarantine. So preparing for the entering Taiwan, the first one is after you accept the accept letter, then our office, International Affairs Office, we will send a student list to the Minister of the Education. Then they will send to our embassy department. So you can, student can receive the visa. So you can start to apply the visa. And then after you get the visa, you can make a reservation for the quarantine hotel and booking the flight tickets. So about a broader quarantine, you need to submit the nucleic acid test report issued within 3 working days before you board into the flight. So after you arrive, you need to take the taxi. So you cannot take the public transportation. You need to take the taxi, and the taxi from the international airport to Kaohsiung airport is about 2,600. Then you need to take 14 days quarantine, single room, and then after you come out, then 7 days self-health management by yourself. Okay, so then it's finished. Okay. So Taiwan is very safe place. Right now, Taiwan is the lowest accident rate of the COVID-19 in the world, and everyone can live in normal life. And we also provide a real lecture in our university. We don't have online lecture, so student can come and go and go to the classroom. Okay. So that's, I think, welcome to you guys to apply the NSYSU IPPS. Another one I would like to introduce about our institute, because our institute also belongs to the IPPS, and we also provide a master's degree. So please, I will stop the share about this. Then I will keep going to share another file. Okay. Okay, do you guys see the screen? Can you see the screen?
Yes, sir. Yes, sir, it is visible.
Yes, sir.
Okay, thank you. So as you can see, this is our campus. It's a beautiful harbor and a beautiful beach view. Okay, so actually in our university we have 6 colleges, so it's quite comprehensive university, and it's very beautiful. We have mountain, we have sea. Okay, and this is Kaohsiung Harbor. Okay. So our institute is Institute of the Medical Science and Technology, and we established our institute in 2013. Until now, is over 8 years. Okay, so we have a master degree, and we also have PhD degree. So if you go to our website, and you can see the handout for application of international student. So you can see our institute name. So either way, you can apply to our institute. You also can apply to the IPPS. But for a master student, you can apply our institute directly. Okay. So right now we have 8 professors. So we all very young. I'm the oldest one. So now I'm the chair of this institute. So later on, I will introduce one by one. Okay. So I'm Professor Chengxin Zhuang. So I am doing a lot of biosensors, and we also doing the IoT sensors like a wearable, flexible wearable electronics. So if you can see this one, right now we try to do the stretchable sensor, and then we can monitoring your breathing. And right now we also developing some temperature sensor. Maybe later on my student will introduce you a little bit. And in our lab, we are doing the electrochemical sensor for a long time, and like a paper-based sensor or plastic-based sensor. Right now, especially focus on the chronic kidney disease and bladder cancer. So because in our lab, we try to do the smart sensor for urine-based sensor, okay. And this one is a heart and pressure sensor for endoscope. So we also try to develop the hardness detection for your oral cancer. So you can see in our lab, we can do this kind of the small sensor by semiconductor fabrication or screen printing fabrication, okay. And Professor Yang, he is a very excellent scholar, and right now in his lab, he developed some kind of microneedles patch and rapid biosensing. So recently, he already developed the COVID-19 liquid-based biosensing, and he also got a big budget to start up a new company, okay. And the rest of they also try to do some cancer detection and based on the nanomaterial. So in our institute, we are doing a lot of the nanomaterial related to the medical application. And Professor Yang, his background is from chemistry engineering, okay. And Professor Liao, she is doing bio materials and doing some kind of like virus, by using virus to do the drug delivery. And so he developed a drug delivery system based on the virus, and also doing the photo-induced tumor therapy. So Professor Yang and Professor Liao, they also do some animal model to test the cancer therapy. And Professor Fan, her background is from chemistry, and right now he set up a optical system, and this optical system can detect the single molecule. So right now he focused on the single molecule, like a DNA and a protein interaction. And Professor Chen, his background is from like information bioinformatics. So right now he is doing the molecular dynamics simulation, especially for the drug screening. So he can do the drug screening for specific protein, and then you can apply to the precision medicine. And Professor Lin, his background is EE. So in his lab, he set up a brain signal interface, and they try to monitoring the brain signal, especially for the motion control. So I think this is quite advanced, and I think in the future they can apply for the long-term care, especially for the elder people. And Professor Li Qiwei, Professor Li, actually he also is a medical doctor, but he is already full-time professor. Okay, right now his research is focused on the clinical toxicology based on the mass spectrometer. So he tried to very rapidly to examine what kind of toxicity you add the wrong material, wrong foods, and they can very quickly pick up the right therapy method for you. And Professor Chen, her background is from material science. So right now he is trying to do like photocatalytic materials and also bioceramics, nanoparticle and coatings. So he can synthesize by their own, and they can do the artificial bone materials, also using the 3D printing to print the ceramic base implement bones. Okay, so all these research topics are very interested. If you interested about our any one of the professor, you can log on our website to see any topics you like. So you can see your university, MIT University of the Institute of the Applied Science. We visit your university 2 years ago, I think. And we also collab with the main large hospital in Kaohsiung area. So I think a lot of prospective collaboration could be collaborate with your university in the future. So we in our institute, we have 8 researchers, and as you can see, our paper is quite diverse. Okay, so we have computer science, physics, chemistry, chemical engineering, material science, engineering, biochemistry, pharmacology, and cytology, medicine. So I think we accept any kinds of the student, and you can find your own way in our institute. So this is the statistic data. I think each professor maybe will publish 4 to 6 papers per year. And the best thing is about half we publish the very good journal. It's top 10 journal. And so so it's quite, I think it's quite research-oriented institute in our institute. And our performance is higher than the average of the College of Science or College of Engineering. So here is our publication list. I think it's quite easy to understand. So I would like to stop my talk here, and maybe I would like to introduce my student to give some briefly introduction of what he is doing right now. Okay, so Amy.
Yeah, okay, thank you, Professor.
Yeah.
Yeah. Can you see my screen?
So I didn't see your screen.
Okay. Okay, इसको ठीक करो ना, ये इधर लाना है। Wait. Teams का है। Can you see it?
No.
No.
Oh, yes.
Yeah. Yeah, okay. So I am Amit Kumar, and I am a PhD student at MANST Lab, and my advisee is Professor.
I cannot see. Oh, okay. I can see now. Okay, I can see now. Okay.
Okay. So.
Oh, this view is my office view. Okay.
Yeah. So this is a view from our lab, and it's quite beautiful. So this is my research about synthesizing silver nanowires by one-pot process, and it is a 5-step. It is a 5-step process, You can see from the starting, like I mixed 3 chemicals, PVP, ethylene glycol, AgNO3, and calcium chloride to make silver nanowires. And in my research, I synthesized silver nanowires of aspect ratio more than 1000. So these are some results from my synthesized silver nanowires. So you can see the silver nanowires from the SEM image. You can see like the silver nanowires are more than 100 micrometer, and in the smaller picture you can see the diameter, and the diameter is less than 100 nanometer. That shows the aspect ratio of the nanowire is more than 1000. So these are some characterization of TEM and SAED, which shows single crystalline silver nanowires with a twinned structure. After this, as we all know, silver is more prone to oxidation, so we start to make it biocompatible by covering the silver nanowire with the gold. So in the starting step, I mixed PVP, citric acid, and NaOH to make a composite, and then I add silver nanowire. And after that, I add the gold precursor to cover the silver nanowire with the gold. And you can see from this picture, the silver nanowire is completely covered with the gold layer, and the gold layer is very thin, like less than 20 nanometers. So you can see 95% coverage of AU on the AG surface. And after that, I do EDS of my synthesized gold-coated silver nanowire. And from the EDS spectrum, you can see like the AU atomic percentage is 3.6. That shows like the gold is coated in a very less amount, but completely on the surface of silver nanowire. After that, I do elemental mapping, and in this one, you can see like the red color shows the silver, and the green color shows the gold. So in the fourth picture, you can see like the orange color is silver and the green is gold. So the green color is completely covering the orange color. That shows the gold is completely covering the silver nanowire and making it biocompatible and antioxidative. After that, we try to make temperature sensor, and in that I try to make a nano composite of polyurethane, polyethylene glycol, and gold-coated silver nanowire. And these are the steps in which I first make polyurethane solution and then mix it with PEG and silver nanowire, gold-coated silver nanowires. After that, I put it on a self-printed interdigitated electrode to make a sensor, which has been shown here. And you can see the thickness of the sensor is very less, around 200 micrometers. After that, we do the testing in a humidity control chamber. So only the change in temperature was responsible for the change seen in the multimeter. After making the composite, I do FTIR studies of the nano composite, and you can see the PEG structure and PU structure on the sides. So PEG structures only has COH atoms, and PU structure has COH, and it also has N structure. So FTIR shows like the PG and PU are cross-linked, as the peak shown at 1.72 into 10 to the power 3 shows a carbonyl ester group that shows they are cross-linked. After that, I do the characterization of SEM and EDS together, and I do the EDS at specific silver nanowire region, and I found at specific region only PEG connect with silver nanowires and no nitrogen connected. So this will be helping me in explaining the mechanism of the temperature sensing. And after that, I do on a big area the EDS, and I found that N atoms were available. N atoms here shows the presence of PU, which is the structural polymer in my nanocomposite, and the PG shows the change in temperature. After that, I made the sensor, and you can see in this video the sensor was stretchable. After that, I do some temperature testing, and in this one, you can see when the sensor is heated with IR lamp, it shows a decrease in resistance. That shows negative temperature coefficient of resistance of the sensor, which is very sensitive. After that, we do the thermal testing of the sensor, and we found that with the change in resistance, with change in temperature, there is a big change in resistance, which shows thermoresistive property of nanocomposite, which is very sensitive in range between 20 to 40 degrees Celsius. After that, we measure the delta R by R of our sensor, and we found a more than 90% change in delta R by R. And we found that the change in resistance was very good in human body range. So we can say like our sensor is very good for measuring the human body temperature and continuous monitoring. Yeah, thank you.
Thank you, Amy. So, RK is here or not?
Yeah, he's here.
Okay. So, RK, do you want to continue your part?
Yeah. He will be sharing his PPT.
So I think Amy and RK are both graduated from MIT University, and they already come to our lab for 2 years. So, so later on, I think any student, if you're interested about anything in our university or in our lab, please just go ahead your questions, and Amy and RK, they will answer your questions. Okay. So, RK, you can start to report, to present your part.
Okay.
Hi everyone, I am RK. I am a second year PhD student in National Sannyasin University. The current research topic that I'm pursuing is screen printed electrochemical biosensors. I think so. Based on cuprous oxide nanocubes for detection of creatinine. So this is the synthesis process. We use a seed-mediated synthesis protocol wherein we use the copper chloride as a precursor and sodium acetate as our reducing agent. And with each aging time and increase in the number of seeds, we perform this method to synthesize about 4 different kinds of cuprous nanoparticles. As you can see here from the TEM images, the first one is a nanosphere with a range of about 80 to 85 nanometers. And from the other 3, we can see this sample D, G, and J. They are nanocubes ranging from the size of about 40 to 45 nanometers. On the right-hand side, you can see the screen printed carbon electrodes that has been modified with the first sample, the second, third, and the fourth. And these are the SAED images and HRTEM. As you can see here, you can see the crystal lattices, and you can simply say that they are single crystalline. And if you can look at the lower right, it says that the difference, the range is 0.3154 nanometer, which is approximately about 30 Armstrong. And this corresponds to the 110 facet of cuprous oxide, which is also a confirmatory test as to show that our nanoparticle synthesizes cuprous oxide and not cupric oxide. And this is the particle distribution and the EDS, which shows a 2:1 ratio of copper to oxygen, which can relate to our proof that it's Cu2O. And if you can look at the particle size distribution, there's a narrow graph you can see from about 40 to 45, which means the synthesized particles are of a single file, and you can see that it's concentrated mostly around the 42 to 45 range. And this is our electron modification protocol. It's a simple drop cast modification where we use 40 microliters of cuprous oxide dispersed in DI, and then we dry it in ambient temperature and then transfer it in 60-degree oven overnight. The third step is necessary because if we do not transfer it in an oven to let it sinter into the surface of the carbon electrode, when we use it for sensing the modification of Cu2O, it kind of dissolves into the solution and leaves very quickly, which is undesirable. And this is the sensing mechanism. When we add the human urine or sample, depending upon what kind of testing medium we are using, the Cu2O nanocubes, it reacts with creatine, and it forms a complex, a soluble complex, and it dissolves into the solution, which in turn decreases the reduction peak potential. And it's worth mentioning that the peak here is because of the CV, the DC current that we're applying, which comes around 0.168 volts. And this is the preliminary results where we use about 0.12 micromolar to 0.84 micromolar. And the two graphs on the right shows the repeatability test with very marginal error bars and a linearity of 0.96 R-square value. After the preliminary test, we try to use this sensor to test if we can use it for detection in serum. And this is the final results. And we have a very linear graph from about 10 micromolar to 200 micromolar concentration of creatinine. And it is also required to mention that a healthy range of creatinine is from 40 micromolar to about 120 micromolar. If your creatinine concentration in serum is less than 40 or greater than 120, then you might have a chance of getting impaired kidneys, which is also an indication of chronic kidney disease. So if we have a range from 10 to 200, which quite exceeds the healthy range as well as the harmful range, we can successfully determine if a person has functioning kidneys or not. And if you can see here, we have quite a linear range of 0.98 R-square value, but we have also done another graph in which instead of taking the current potential, we use the log of the current, which kind of increase the linearity to about 0.999, which is much more better. Thank you.
Okay, thank you, RK. So now we want to accept a few questions. So maybe Professor Shaker can help us to host this section.
Students, now you can put your questions. Please unmute yourself first and then put your question. Either way, you can write the question in the chat box also if there is a connectivity issue.
Yeah, if you can write in the chat room, that would be better. So no questions?
I have a small question on behalf of students, sir.
Okay.
If you allow me. I actually missed the initial part of the presentation. So do they have to appear in a certain kind of a test, or there is a scrutiny of the candidates based on their performance in their MSc and previous classes?
So Amy,
Yeah,
can you answer?
yeah, of course. Professor, there are no required tests or like entrance for the admission in NSICU. You have to apply here through the application link. It opens every 6 semester, and there you submit your documents and your academic performance along with the research work you have done in your previous degree, like in master's research or in bachelor's research. And based on that evaluation here, they like select you in the university for the upcoming courses.
Okay, and again, on behalf of students, because there may be a lot of questions for this.
Okay.
How much is the financial support that the student can get? I mean, there.
Yeah. Okay. The normal scholarship for the IPPS students is 15,000 NTD per year. Per month. And apart from that, on the basis of evaluation, some students are like provided free dormitories, and some students who are like not provided free universities. So it's based on evaluation. But when you come to IPPS program, it's an international PhD program students. So in that you get 15,000 per month, and it's quite suitable to like expenses here. And apart from that, if you can do work in the project, you can get some monthly salary from your professor or from the project that you are working there. Yeah.
So students, please go ahead with the questions. Professor Chuang, let me get Professor Yadav on board if he is available. Let me call him and.
Sure.
Yeah.
Welcome.
Yeah.
Actually, I cannot use the chatting room. So maybe I'm not registered in this software, right?
Yeah, maybe.
कहाँ से खुलता है?
I request you to wait for 1 or 2 minutes. I'm expecting Professor Yadav to join. I think he's in a class and he's not able to pick up phone. I have requested somebody to actually go there and request him.
Sure, welcome. Any kind of questions is okay.
Any students? Yeah. As Soumya Sharma.
Good morning, sir. Sir, I have a question to ask.
Yeah.
Sir, I want to ask the research field in the field of biochemistry, research aspects in biochemistry.
Yeah, my colleague RK is doing that, biochemistry.
Okay. Hello. If you want me to specify what kind of research is there in biochemistry, I mean, we generally have.
Rakesh, for a moment, for all your information, biochemistry and chemistry students, Rakesh has completed his Master of Chemistry, Applied Chemistry, a Master of Science in Applied Chemistry from MIT University, Haryana. So you can feel free to interact with him, or Amit has completed his MSc Applied Physics from here. So they are our alumni, and
Yeah.
your